That part we'll worry about in a minute. Just get them out. We're not using them yet, so. You're doing this first. Hold on. Here. So, like I said, you're gonna have an exit ticket tomorrow. I'm pretty sure this is it. Nothing else popped up during the lesson I thought would also be a good like exit ticket for the point of the lesson we're in. We're not going to cover enough tomorrow for me to make something we do tomorrow or even Wednesday for you guys. So I mean, pretty good chances this. If that changes, I'll let you know. It could be between these two, like I'll make it the bell work or something. But should be that. You just need to know how to tell me, are two figures similar? In this case, triangles, and it'll probably be triangles on the exit. Well, that's why you're practicing it today, so that you get it right tomorrow. Or for you guys, probably Wednesday. Actually, it probably will be tomorrow for you guys. Yeah. So we'll split it up there like we did the other time. I can do the review. You'll basically have the same exact review that the other people get on the same thing again. With probably one more piece added in. And then that way you will have the review and the exit on the same day instead of waiting for Wednesday. I'll give you like a minute. Couldn't take you long if you remember how to do. Pretty sure that I started it before. Again, if I walk over and you haven't done anything, I'll keep an eye for the rest of the period in one of those two seats, or both of them, if a couple of people. Now that I'm being forced to do it, I'm not happy. I mean, I don't care if you're happy. I ran out of time last class. So let's, yeah. So I made these up. I didn't make them, but copy them. This is like a review overall quadrilateral sheet. So you can't do the last Friday with the deadline for angles and polygons and parallelograms, but you still have a little bit more on parallelograms, rectangles, rhombus, and square you can still do, plus the trapezoids and kites that, like I said, I've created my own in. So if you want to grab one of those, I help you prepare for those. There's also a summary up here. I didn't copy, but you can take a picture of that. And there's a review video too. If you haven't noticed it, most people probably don't look, but I did a review video that does not include trapezoids and kites, but it has the other stuff on it. I don't really do any problems, but I just go over what concepts you need to know for each figure. Give another 30 seconds. If you care, the grade from that district thing you did last week or in performance matters, I mean, they were in there 10 minutes after. The highest score was 94. One student only missed one. Okay. We had a few, I mean, I don't know which classes, but there were a few people that got in the 80s, and then quite a few that got 70s or 60s. Average though was only a 45, which means a lot of people didn't know what at all. I had some high scores and a few really low scores too. All right. So quick review, what's dilation mean? Dilation, Caden. Right here. Now that you've read it, what's it mean? Simple or figure. Yeah, big or small. We said we're going to take an image, make it bigger or smaller. That's a dilation. That's it. The only thing you need to remember is when we make it bigger or smaller, it stays in proportion. That's the big thing moving in a similar figure, that word proportion. All that means is that we have, and we learned this term, so I'm going to use it. We have the same scale factor for all of the sides. If we know that it's a dilation, if we pick any two sides and create a ratio, and we said it was final image over pre-image, so we'll do that in a second. We said that would give us what's called a scale factor. Then if we took different sides from those same two images and we did a scale factor for those sides, it would always be the same scale factor if we know it's a dilation. So next we moved into this thing called similar figures. All a similar figure meant is that we did a dilation. It's the same concept. Nothing changes at all. It's just now we're calling two figures similar figures instead of saying one is a dilation of the other. So if we had similar figures, what is true between two similar figures? Ashton. Okay. Abby, what's true? There's two main things. So if you know nothing about similar figures except for really dilations, these are the two things you need to memorize over and over and over. So if you know two figures are similar, one's a dilation of the other, give me one thing out of the two that is true. One thing you can say about it. Give you a hint if you're not sure. So the sides are in proportion. That's one thing. The sides are in proportion, or the scale factor would be the same. We just talked about it. Now there's one we didn't talk about. I mean, we talked about it the other day. We didn't mention it yet today. What's the other thing that's true about the two similar figures? Give you the hint. Not the angle. Not the angle. Angles are congruent. That's your two big ones for dilations and similar figures. Angles are equal. They're the exact same. They're congruent. Assuming you match up the correct angle with the correct angle. Sides are in proportion. So you did this exercise the other day, example 1, I think it was, where all you had to do was take all the angles, A, B, C, D, and match them up in order with the other, whatever the letters were in the other shape. First letter matches up with the first letter, second with second, and that's the angles. The angles are congruent. Then you created proportions, which is what we're about to do right now, in order to show that you had the same scale factor. So if I do the proportions here, because I don't know anything about angles, I can't use that in any way. If I do the proportions here, and if I come up with the same exact scale factor, then I have similar figures. If I don't, as soon as I get one scale factor that's different, it could be the very second one that I get, then I'm done. It's not similar. So with that in mind, does anybody have any other question about something I didn't give you? What is it, Jeremy? Wait, actually, what's the scale factor? Well, let's talk about the formula. What's the formula for scale factor? So one side, I'm just going to write an abbreviation, but one side from the final, and then the matching side from the pre-image. That's the scale factor formula to find that out. But what's the problem with what I gave you here? I didn't tell you that, right? So here's the kind of conceptual part. I didn't ask you what is the scale factor. Because if I did, then I would have to tell you those two things. I just want to know if they're similar. I can make either of them the final image. I can pick because I'm going to either get the same exact scale factor or I'm not. Doesn't matter where I start. You'll see, we're going to do it. So if you don't understand what I'm saying, you'll see it. I just need to make sure I match up. And I think I told you this was not the way you could do it the other day, but I'm sort of changing that. It's not in the book. It's more of a matter of opinion almost. If you have letters the safest way to do it is to match up the letters, like to say this side and that side. But theoretically, if you also have all the numbers, if you match up the smallest and the smallest, the biggest and the biggest, the middle and the middle, and you get the same scale factor, I mean, even if it's not with the right letters, that technically would still be a similar figure. The similar figure has to do with being able to have an image land on top of the other. And if you got the same scale factor, they would land on top. So I'm going to ask the other math teacher if she thinks that's incorrect, but it won't come into play on my quiz, or I don't even think on district. So don't worry, just do the scale factor. If you get the same scale factor for all sides, it's very good. Again, if you didn't understand that, just ignore it and do what we're about to do. I don't think it's good. All right, so with that in mind, I can make either of these the final image. Which one do you want to be the final? Next. Next, which one do you want to be the final? Left or right? All right, so we're going with the right. I'm going to start with the smallest side. It doesn't matter where you start. So that's going to match up with that smallest side. Then I'm going to go to the middle side, which over here is that. Don't look at the shape. That does still apply. Largest would match up with largest. All right, so now I would say, yeah, we said this one. So what would I do if this is my final? What would I do? Kanaya, I want to get my scale factor for the smallest size. So which one over what over what? We said this is the final. And I'm doing smallest side and smallest side. So 2.2 over 1. Two smallest sides match up together. That's pretty simple math. Gives me 2.2. Now, if you had done it the other way around, you would have that. Somebody on the count, I think it's 0.0 or 0.45 maybe. Somebody do that real quick, just confirm that. Oops. Yeah, it might. Is it exactly like that, or does that keep on? Is it just 0.45?
Yeah.
All right. So you'll see that we'd still get the same answer no matter which one we put on top. All right. What do you want to do next? Which number?
2.2.
So here's the one thing that I can see, or I have seen in the past be a mistake. If I start with 2.2 being on top, so from this triangle, everything on top has to be from this triangle. Just don't flip it around and accidentally now put one of these on top when you match them up. So again, 5.5 works. That's for this triangle over here. So what would go on the bottom of that? We're gonna leave off. Xavier, what would go on the bottom? If I picked 5.5 on this one, what goes on the bottom from the left? Which one is this? Middle, right? So I need the middle over there.
Let's be the middle.
So 3, not 4. 4 is the largest. It's going to go with the largest.
That gives us
So 3.
Let's see 3.
So I got that. What's that mean?
Not the same.
We're done.
Not.
We don't have to keep going. As soon as you get a different scale factor, you're done. They're not similar. You don't need to check any other sides. Really quickly in the calculator or in your head, somebody say 3 divided by 5.5. 5.4. Is that right? 0.54. So again, you would have gotten a different scale factor that way too. It doesn't matter which one's on top or bottom. The only time that matters is if I ask you specifically for the scale factor. And if I did that, I would have to give you which one is the pre-image and which one is final. You couldn't figure it out with that. All right, so that's something along those lines is your something along those lines is your exit ticket tomorrow.
Yeah, it's gonna be easy.
And we talked about the fact that angles would be the same if they were similar also if we didn't have any measurement. All right, so here's what I want you to do. You should be able to do pretty much all of these, really. We already did we did example 1 also, which comes into play. Example 1, when you go to the practice problems, the first 2 are like what we did yesterday in example 1. If you want to do the check, you can. That should not be difficult. Example 2, I think we did that. We rushed through it, but you can do the check, which we did not do. So that's page 81 is the check. And then after you do those, so basically example 1 and example 2 and the check problem, then do page 85, 1 through 6. And then I'm going to give you 7 or 8 minutes to do as many as you can. If you think they're super easy and you want to stick to whatever you think is harder, then whatever you think you need to practice. Give them another minute or 2. 2 minutes.
We can do same thing, right?
Yeah, I mean, this is today, the stuff from today is not super difficult. I don't think so. We will get into some stuff that's a little tougher, so take advantage of what we're doing today and make sure you get this stuff down. If I walk over, remember, and haven't done a single thing, then get up here with me and we'll work on it together. Clear that desk off.
Where is it similar or not similar, right?
Well, it depends on the problem. Which one are you doing? Are you doing that one up on the board on the right? And this one, you're telling me is this, does anybody have a question about what's going on in that check problem in the upper right? Anybody not sure of something? And you should be, but I did get this question from some people. If it's just saying, are they similar? You just make sure you always put from the same figure on top. How are you going to check all of the sides when you don't have all of the sides? How do you know? What is it? Again, these are rectangles, so you know the opposite side is going to go.
Not
Parallel, any parallelogram would be that. And if you have 4 90-degree angles, it has to be a rectangle. That's the only shape of 4 90. A square is a rectangle, so don't say you could use 100%. A rectangle is not a square, but a square is a rectangle. I know, right? You started. Now you're on. Once you just leave the humor. I don't know about that. See, look at that. Worked every time. Oh, I was gonna do attendance. Hold on. Let's see who we got.
You
got live practice time. No, you cannot go. You got a long line of people. Why don't you go ahead and go? You can start the line and. No, Jason.
Oh, wait.
See. Oh, I forgot.
Why? Oh, it's on the parallel angle.
Okay. That is Ashton.
So would it be 80 in here?
You.
This.
Yes.
I need help.
What question? While I'm doing this, I'm sure I can probably.
I don't know how to remember one is paid 85.
That's just like, look at example one. We already did example one, just like that. I mean, literally, just like that. Yeah, remember the practice problems tell you which example matches up. And I only give you practice problems when we've already done the example, so just go back and look at the example. I mean, they actually did the example for you, really. Whole thing.
Yeah.
Oh, let's see. It's probably a big. Oh, that's not one. Hey. Why are you searching this? You didn't need me to.
Yeah, I was like, oh.
Hey, you never know. I might just check this out. I was reading it. Thank you. You guys be good. There.
Oh, wait, never mind, never mind.
I'm doing attendance. I'm recording, so I don't want to put it in phone. That one up there?
I can't do this square one.
It's not a square. How in the world do you guys do saying that it's a square? What's true about a square? What's true about a square? Number one thing, all sides are equal. Are the sides equal? The two numbers that they give you, are they the same?
No,
Then it can't be a square.
it's a rectangle.
Think about it. It is a rectangle. One side is 8, one side is 10. It can't be a square.
I mean,
You just said a minute ago a rectangle is not a square. I know you said square.
yeah.
I do. I'll give you a couple more minutes and we'll start going over them. Yep. Mhm.
They're not that dirty. But they did it.
No. Page 85, 1 through 6, I think. So let me ask you this. I said, how long ago did you?
I was doing the.
You said it 10 seconds.
So did the other signal?
You only give it
There are just so many holes in your story at times.
Hold on, right?
So many holes. Yeah, but
Yeah,
not 10 minutes.
Yeah, right.
That amount.
Easy, man.
Faster would go for at least 70.
That was good before. It was so before we even.
Oh, I didn't actually go into like you.
So.
So no, this, be careful, this, you're saying they're similar.
Look, 80 to
Angles are very different. They actually
It's not math,
longer than
writing.
10. That's simple.
It's like
Something Oscar. What's the goal? Not often. Oh, we're supposed to. Yeah, same thing with the one equal sign. Let's go to group 3. What? Up there last time. You got it real off, didn't you? All right, it worked. We'll go over them in a minute. You might see how we're doing back here. Yeah, that's good.
I mean, I'm not.
Go.
Get on there.
Can you come here?
We literally.
I just said come here, and you ain't exactly, you ain't doing
All right,
anything.
you heard them ask for help.
Exactly.
Apparently wasn't that loud.
Then I said.
Here too. Yeah, I see, can you help me?
You should have just learned it up.
Right back. Pretty deal with it. I need to help with the second one.
Got it right. That's the exact same thing.
That's what I'm saying.
So you got that one done.
I did this, but I.
What'd you get?
No, they listen to
But again, what?
They just get it, just try to find the process, just recall it.
No, that one.
Where you?
It's this one. Check on like literally the one up there. Where I really- Yeah, no, you should do that and do that one. That's why we were talking about it being a rec. What is it?
It's not really.
It's not a quadrilateral because all the sides are.
That didn't say anything.
Not really,
That's not a square. That had nothing to do with it.
Same thing.
I'm just saying it's not a square. That had nothing to do with it. The question is, are they similar? How do you determine similar?
So you might say that, Mr.
I
Gill?
said it's not a square, because the two sides are different lengths. It can't be a square if you got two sides.
And we're saying-
Not being similar.
And then just cover the rig of the.
So what is it?
It's rectangle. So if it's a rectangle, what's true about the opposite side? No, the opposite.
Remember.
You got a rectangle.
Uh-huh.
Is there ever gonna be a rectangle where the top and bottom are different lengths? I can know.
I
Left and right. Huh?
Why did you put a rectangle? Why put no?
Class.
You are gonna be sitting up here. You're gonna be sitting up here, not tuned in when I say stuff. You've said so many things already that have nothing to do with what I asked, nothing to do with the problem, and clearly haven't been paying attention. So we gotta get you up front, so I can constantly check on. What did you get?
Here, Russ.
Oh, yeah, that's right. That, I see that part right.
Oh, yeah, do more, right? Oh, that's too big.
Like, what?
Oh.
I was good, like.
Have a seat.
Yeah.
All right, we gotta go over now, so I'm dead serious, but you gotta sit up. No, oh, really? See, that's probably your math skills right there. It doesn't get any closer than where you are. It really doesn't get any closer.
You literally answered the question and you gave us the wrong answer. How you gonna get
I did not. That's what I'm talking about. You don't even know what I said.
You know what you said?
I said it is not, how is it gonna be a square when two sides are different lengths? But that's not what the problem is asking you. Because somebody said it's a square, and I said it's not a square. You, see, this is my problem. You are going to be up here because I can't do this over and over again. I can't. You're sitting here and telling me, I said, hey, you know what? We'll go back and watch a recording together. How about that? You can sit in here and lunch and we'll watch it together. And I guarantee you, I never said anything like what you're saying. So the only thing you need to understand, or not understand, but sometimes you have to fill in information. You have got to understand what the other sides are in that figure. And that'll be the case in a lot of figures. I mean, if I tell you it's an isosceles triangle, an equilateral triangle, a parallelogram, all of those figures have sides that are congruent. You may have to know that. It may not give you every single side in every single problem. So with that in mind, what else can I fill in on that? Shane, what else can I fill in on that? So AB is, well, no, I need more than that. In each individual figure, I need more because I got to test all four sides. Yeah, so that's 10. It's a rectangle. Opposite sides are congruent. 14, 12. you're gonna have to understand. I mean, again, you've been dealing with rectangles since your third, so I've never seen one before sometimes. Or a square, like there were some people on the quiz for the square. I had no clue that all the sides were the same on the square. At least they didn't. They told me information that was different in their problem. So now we can test out. You can create proportions, ratio, scale factor, whatever you want. Doesn't matter which one you put on top. So if I wanted to start with the little one on bottom, that's fine. 8 would go over the 12. I'm not going to need to do the 8 and the 12 again, so I really don't have to test those. Now I just need to do the 10 over the 14. Make sure if the 8 is on top first, then the 10 is on top second. So now if you do the math on that, what do you get? You get 2/3, which is 0.6 repeating, right? And then what's the other one?
7.
This is, and remember, that is not 0.6. It is 0.6 forever. Do not use 0.6 to compare. Sometimes I could write another fraction that is 0.6 and they wouldn't be similar. You need to understand 0.6 repeating is not 0.6. That is a totally different number. And then what was it? 0.71 or something? I mean, again, I'd use the fraction of what I would use. But if you need to convert it to compare them, then you need to say whatever the number is to as many digits as you need to show that it's the same, or if it's clearly different, then you can show me the two that are different. But if you're going to do decimals, you need to put all the decimals out to the end of the calculator every time you do similar figures. I'm pretty sure if I remember correctly when I created the quiz, I did put one there where if you only carry it out 2 or 3, you're going to think that they're the same, and they're not. There's more decimals left after the first 3 on one of them. So again, that's 2 totally different scale factors. Clearly that's different, so shouldn't have any issues going. Those are different. So those are not similar. You do the exact same thing that we just did there on, I think it was problem number 3, with one exception, which I'll tell you. I thought it was 3. Is it 5? What's 3? I thought 3 was. Oh, well, yeah, but you do the same thing. I mean, maybe. Where's the practice? Oh, they're there. I'm not going to go over these. If you need to, go back and look at example 1. That's the same problem as example 1. When you're matching up the angles, so match up the angles, you just go in order. A matches up with W, B matches up with X, C matches up with Y, D matches up with Z. You just go in order. Same way when you're doing the proportions for the sides. AB would be over WX. Again, it's in your book. Example 1, they've got the answer done for you. And then if you want to try the check file on your own, you can. And then just make sure you always start with this. If AB was on top, then BC needs to be on top. And it would correspond with XY. And then you keep going and do the other 4. Like, you can get away with looking at the picture, but just make sure you use the letters. And then 2 is the exact same thing as that. We need to go over these. These were a little tricky. All right, number 3. They want to know, are they similar figures? So what do we do? Page 85.
So,
Ooh,
about the letters?
different concept. That's what has to be true about those. Are they? You're done. So what do we do to determine if they're similar? Called on Caden, called on Andrew. What would I do? Like, what's true if they're similar figures? What do we do in the bell work? What did we just do in the last problem we just did? You can be sitting on fun. I'm gonna run out of seats. What do we do? How come you next? You tell me.
No, because I'm giving the wrong answer.
What do we do? Top, Jeremy, what do we do?
Okay, what, here's one.
So I need to know if those are similar figures in number 3.
They're not similar.
Mess up that.
Shh. Say it again, I didn't hear you.
Smallest number.
Yeah, I'm doing the sides. I'm finding the scale factor. So if I have all the sides, smallest matches up with the smallest. Middle, so this would be middle, matches up with middle. And largest matches up with largest. I'm putting shapes just to show you which sides correspond. So I could create scale factors. I'll start with I'm going to start with the right one, put the right one on top. Doesn't matter which way you do it. So 11 would go with 6.4. So again, I just took the 2 largest or longest sides. So somebody divide that out. What'd you get? What's 11 divided by 6.4? So again, that is the scale factor if this is the final image on the right, which we don't know that, but it doesn't matter. I missed 1 point what? All right, that's enough. I don't think the others close. So now again, I just need to make sure I keep starting over here for my top number. I'll pick 7.4. I could have done 8 point. So 7.4 is the smallest, the shortest side. So I need to take the shortest side here, which is 4. What does that give me? 7.4 divided by 4. 1 point what? So again, I'm done.
Done.
I didn't get the same scale factor already. I'm done. Maybe. Yes, absolutely. There's no math necessary in this one. What's true about similar figures? Proportions, but the angles have to be congruent, right? They're not congruent. That's 36 and 51. That's 42 and 48. I didn't need any math at all.
Number 4 is.
As soon as you see the angles are different, they can't be similar. So that was, if you really understood the concept, you didn't have to do math on that. What about this one? This one's a little tricky. So there's no number, no angles, no numbers in the angles. So what would we do?
Angles just start on the same.
Say it again. What else do we need to understand about this figure? It's not in there. So again, this is where you need to understand that you can do something else. So what will this? They do, right? Isn't it true that that side is part of both triangles that I see? So I can say, well, those triangles share that side, meaning that's congruent.
Yeah.
Now what can we say about the 2 triangles? That's the same triangle.
Yes.
Side, don't forget this stuff. Side angle side, side angle side, side angle side means those are congruent triangles. So now the question is, are congruent triangles also similar? Absolutely. Because again, if we know we can map one triangle onto the top, which is the definition of congruent triangles,
Yeah.
then we're done. We don't even need to do a dilation.
Yeah.
So congruence does prove similarity, and you guys can do, this one's a little tough mathematically, just make sure you are careful about matching up the sides.
Yeah, dude. What about the three? Doesn't matter if it's connected.
You just need to do little, smallest side, you gotta figure out which is the smallest, largest side, and then middle side, like just make sure you match up the sides and see if you get the same scale factor. Or, actually, you don't even, yeah, you still need to do that. Sorry, you do. You really don't need to do that, but we haven't learned that one. We'll learn something next class that would allow you to actually not even do math on number 6. Exit ticket will be, for you guys, the exit ticket will also be tomorrow. Pretty much on what we did today, so.
Turn the light off.
That's what I do.
Oh, what?